modeling is also doing operation as well as planning also. So these are the power system optimization problem which can be handled in operation as well as planning. Okay. Now, so general procedure. What are the general procedure we have to solve in GAMS? Basically, first thing is problem. What are the problem of related? Means if you go for the unit commitment problem, let us say, so they are having some problem formulation. I mean, it's having startup constraint, it having a ramplet limit, it's having power generation limit, whatever they are constrained, they're having the problem. Then we have to mathematical model. We have to model this problem. Okay, then we have to solve the solver optimization. Solver optimization means whatever we are solver we are using. It may be linear programming, it may be non-linear programming, it may be quadratic programming, whatever be the solver optimization we are taking, then we have to get the solution. So these are the general procedure which have to follow the basically research work in GAMS. Okay. Now, let us say we are taking some simple example. What are the objective function? We have to objective function. We have to maximize or minimize, or let us say the function of x. Okay. So function of x, whatever be the function of x we are defining, it may be x1 plus x2, it may be x square plus 2x, whatever the quadratic equation are there. What if you say the linear equation, that is x1 plus x2. If you say mixed linear non-linear programming, then x1 square plus x2 square. So objective function we are defining as, let us say, fx is having constant, that is equality constant and equality constant. Equality constant means that is g is equal to 0. If you say inequality constant, it may be greater than equal to 0, or we can say less than equal to 0. So we are defining inequality constant, that is hs is greater than equal to 0. Just we are taking the example, means what we have clear to general optimized problem in GAMS. Okay. So these are the types of optimized problem. First one is linear programming. Then we can solve the mixed linear programming. Then we can solve the non-linear programming. Then quadratic concept programming and mixed linear non-linear programming. These are the types of optimization problem which can be solved in general way. If you solve large number of constraints you have large number of objective function. So these are the solver which can be used in optimization problem. Okay, these are the mathematical optimization problem which can be used in general GAMS solver. Okay, so these are the solution technique. We have to consider which type of solution technique we are taking. First of all, heuristic technique, as already earlier I am already said that AI technique we can say, and another is the classical optimization. Classical optimization is nothing but is the GAMS. That's we are done in classical optimization, but in holistic technique, most of the researchers they are doing PSO, simulating alanine, seeker, cuckoo search algorithm, taboo search, whatever they are. These are the different types of GA technique. So these, if you go for GA technique, they are having some power system problem in different population. It depends on population. They are the try to improve it by using some operation. They modify the population solution. For example, GA use the crossover and mutation operator to improve the solution regarding optimizing the objective function while satisfying the constraint. So the heuristic technique having some iteration solution. We have to iterate number of iteration in heuristic. But in classical optimization, you have to give the optimal solution. If you say if you take the linear programming, that interior point method, or we can say branch and branch method, Bender decomposition. These are the different classical optimization problem. If you solve in GAMS, then you can give the global optimal or particularly optimal solution, because they in heuristic technique they are having large number of iterations are there. So that's why we are going for classical optimization to reduce the time. Main important is that this is the execution of time reduction. We have to reduce the time. So we need the classical optimization problem. So that's why we are going for classical optimization problem. Is a good solver. If you go for the GAMS, I will show you some example of how can you solve the classical optimization problem in GAMS. Okay. So if you go, when we are going for GAMS algebraic modeling system, there are some discussion. These are the from of general modeling system. If you click www.gams.com, if you written in Google site, then these are the World Bank. You have Washington DC USA in 1981. He can be published, and it having large number of materials. If you click on those GAMS side, you get the GAMS user guide material, and by using this system, you can use and follow all the instruction how can you install the GAMS and how can you model the GAMS. So whatever So they are having some example are also having. So these are the learning oriented modeling language which can be used in GAMS also. GAMS at a glance, it can be used in the lots of model template. They can be used in development interface. They are the mathematical problem, and these are the simple for design principle. These are the designing of GAMS. Again, if you go for the, if you open the GAMS solver, then it will show at this way. These are the picture of GAMS which can be used in optimization problem. So whenever using the GAMS installation, if you install in our PC, first of all, we have to GAMS installation. So these are the platform. If you install in 32-bit also, it can be installed 64. If you have 64-bit, then 64-bit also. So these are the installation way how to GAMS install in your PC. So if you have license copy, license file, basically we have license file because in MNIT Jaipur they are purchasing the software of GAMS installation and they take the license file of them. But if you trial version, you can run the program most of the variables. Okay, you can solve this. Means if you have short most objective function, if you have more than solution, then it can be easy to solve. So these are the GAMS installation which can be used in the power system optimization problem. Okay, now these are the pictures of when we open the file. They are the finding. These are the match partitioners. These are the print, and these are the run GAMS. If you run the GAMS, then the output will become. So when we open the GAMS, this file will be open. These are the file picture, and you have to write the program. What we are code you have, what is the objective function, what we have set variables, whatever we have. Okay. So these are the opening of GAMS interface layout. So these are the solver which can be used in GAMS solver information. Basically, most of the researchers, they are doing for simplex solver. So simplex solver, as we know, most of the programming doing simplex, that is MIP, mixed integer programming, or we can say mixed integer linear programming. If the system, if the objective function is linear, or we can say the simplex solver, that they are using the simplex solver GAMS solver, which can be used in the system. So these are also the programming which can be used in the GAMS solver information. Okay. So now these are generally modeling system in GAMS language, which can be used. It as the part of the source sheets. It can be say the GAMS tutorial in broker, or these are GAMS user guide. As we already said in RE Rose channel is the book, key book. You can follow this book and you can learn most of the things of GAMS modeling system, how to model the GAMS solving system. So these are the system of the part of GAMS modeling system. Okay. Now, before going for GAMS, these are the general characteristics. What are the democratic texts we can say? Because if you talk about if you write anything, so we have to $sign, on text or off text instruction, or error having. If you have error part, when we run the program, they're having some error. We have to error, and error having indicates point and compiler found error. So they're having some error point. If they are started founding, they are having some error in general characteristics of GAM. Okay. So what is the organization of GAM program? First of all, we have to learn about how to indicate those GAM program, how to follow the GAMS program. First, we have to declare the data. Data means it may be having set, it may be having parameter. Parameter means we have parameter declination, assignment, display. Now model means variable. We're having some variable that is x1, x2, whatever. Equation, we have to decline the equation, then model, then last one is solution. So these are the organization of GAMS programming. Okay. Now what is the basically general structure of GAMS code? First of all, this is the general part. How to use the GAMS code in our solution. Okay. So first we have to define the sets. Sets means if having number of generator, it may be 1, 2, or 3 generator. So we have to define the sets. Next, we have to define the variables. Variable means is the unknown variable. It may be positive variable, or we can say negative variable. Then we have to define the scalar. A scalar means if you having demand, means if electrical engine system, if you have demand, whatever the load you have giving, these are the scalar. So this is a single point of value, that is scalar. Parameter means it may be defined on parameter. We have given some data in table also, or we can define in parameter also. Okay. Now, if we, then we can write the equation number 1, then equation number 2, then equation number 3, and equation number 4. Means you have a number of equations. Means equation number 1, let us say objective function. Equation number 4, let us say inequality constraint. Equation number 3, let us say equality constraint. So these we are defining the in a way of equation. Then we have to model. Model means we have to model in, means let us say all, means we have to take the all the equation or variables or say scalar or parameter. So we define the model, and then we have to solve. Solve means if you have solver of any problem, that is linear programming, or we can say quadratic programming, or we can say linear, non-linear, whatever we are taking the solver. These are the solution technique. Okay, so these are the structure of input, structure, then output. So these are the general structure procedure how of the GAMS code. When we are taking any problem, if it may be mathematical problem, linear programming, if it may be economic dispatch or unit commitment, whatever we are problem taking, we have to follow this instruction. And these are the structure we have to follow the general procedure of GAMS code. Now, so basic component of GAMS code, these are the basic component, that is comment, then sets, then data. We have to take some data. Data means whatever be the data as a maximum data, load data, or we can say generation data, or we can say coefficient data. These are the data. Then we have the variables. We have to define some variables, then equations, then models, then what are the solver you are using, and then output. Okay. So these are the basic components of GAMS code. Now, first of all, what is comment? Comment is the basically line. These are the notation of comment. When we're starting the comment now, just we can write economic dispatch problem. Just like you can written. These are the comment. Okay. And when we're defining the set is the comment of array. Means I already said that if you have 3 generator, or we can say 10 generator, so we can write set 1, 2, 3. We are having, if you have 3 generator, then we can write 1, 2, 3. So you can also write 1 into 3, 1 star 3. So it can be it will be take easily. Okay, so set can be if you comment of one set, you can define 1 is to 3 also, or 1 to 3, whatever. If you have large number of generator, if we say 54 generator, so we can write 1 star 54. Then we have to give the this bracket and then semicolon. So this is the way of how to define the set. Okay, now, so I am giving some example. Suppose that oil cooled oil type light and heavy. These are the 2 oil. If you say oil 1 and oil 2, they are having 2 oil. And if you say the product of refining, so we are defining the product 1 and product 2. Okay, so semicolon. Do not forget this, because if you do not give the semicolon, they are having some error. So these are the, we have to follow the instruction of oil. If you go for product, so we have to define in this way of set. Now, how to write input data is, that is a scalar. Scalar, we have to define the quantity. We can say the demand, or we can say load, whatever we are defining. So we are defining the scalar in this way. Scalar Q to a total refining capacity, that is 15,000. We are defining just a simple example we are taking, that is we have to say in scalar in this way. If you define in parameter, then the parameter decay product demand will be product 1 or product 2. Product 1 having the parameter value with this, and product 2 parameter value of this. You can define also in table also. In parameter, you can define also. If you define in parameter, you having choice. So table PGK, unit of crude oil per unit of product, that is oil 1 and oil 2, and product 1 and product 2. In this way, we have to define this table also and parameter also. Okay. So these are the syntax of GAMS statement. How can you define set element? How can you define the subset? How can you define the index? These are the this we are showing the GAMS statement. How can you define? Let us say, if you say set index, or we can say set, or we can say index, they are having A, B, C, and D. Okay. So we are defining just a set as A, comma B, comma C. As we say earlier also, how can define the set? So if you have 3 generator, or we can 2 generator, or we can 4 generator, you can define A, B, comma C. Syntax set name of set. You can set the name of set. Whatever your set name means, if you can, the name of set is generator. If you can say or name of load, so what is the name of set, and we can write the element. Now, if you talk about the time period, If you talk about the time period that we are indicated in a